In this video, I will explain to you what is an acid and a base using the Lewis definition. So, the Lewis definition is the last definition we'll be talking about. We already talked about the 5-sentence definition, the Arrhenius definition, and the Bronsted-Lowry definition for acids and bases. Now, 5 sentences focused on senses, as it says. Arrhenius focused on ions produced, and Bronsted-Lowry focused on protons given or accepted. So Lewis focused on something a bit different. He focused on electron pairs. Not just electrons, it's a pair of electrons. And what we call a Lewis base or a Lewis acid. First, a Lewis acid, he said, was an electron pair acceptor. So, electron pair acceptor. And well, a Lewis base would be an electron pair donor. So a Lewis base would lose electron pairs, and a Lewis acid would accept or win electron pair. And the following section is a little complicated to explain because I haven't talked about Lewis structures, how to draw Lewis structures. But really for now, all you have to know is that a Lewis acid accepts electron pairs and a Lewis base donates electron pairs. So I will still be talking about like how it works with an example, but if you don't know how to draw a Lewis structure, don't worry for now. This until this minute is it's all you really have to know. So I'll teach you how I'll make a video on drawing Lewis structures later as I make more videos, because we haven't really gotten there, but I'll definitely do it. And hopefully you will be able to come back to this video and understand what I'm talking about in the following minutes. So, let's look at an example. Let's look at a reaction that you can say it's very common. We have hydrogen ion just flowing there, and it reacts with a hydroxide ion. Well, what this forms, this is aqueous by the way, is H2O, right? So to picture this, you would really have to draw the Lewis structure. So this would be the H plus just there. There's really no Lewis structure for just an element or an ion. And hydroxide is drawn as, so let me put a plus here, O, you have a covalent bond there, and an H, and you have 1, 2, 4, 6 pairs, 6 lone pair, 6 electrons. So this means that there are 3 pairs of electrons. I forgot to put this is liquid. And so, as you can assume, what will happen now is that this will kind of connect or react, and it'll form a water molecule. So you will have the oxygen there, you have your hydrogen here, and then this hydrogen will get in there, and with one of the pairs, it will form a covalent bond. So this covalent bond, if you really look at it, it is made of a pair of electrons just combined together. That is how a covalent bond looks, because it is sharing of electrons. So let me erase this. Okay, that is our water molecule, and we have a pair here and a pair here of electrons. So oxygen still has 2 pairs of electrons. And well, we said that our electron pair donor is the base, and the electron pair acceptor is the acid. So in this case, you have to ask yourself, which of these molecules, which of these compounds is losing a pair of electrons. And well, you can just see that oxygen just finished with 2 pairs instead of 3, which it had at the beginning. So you can say that the hydroxide, the OH, gave or donated this electron pair to the hydrogen ion. So this would be our Lewis base. So Lewis base. And then the one that accepted this electron pair to form the water molecule was the hydrogen ion. So it would be our Lewis acid. And well, that is how Lewis defined an acid and a base. The base being the electron pair donor and the acid the acceptor. So if you can figure out which one lost an electron pair, you can figure out which one gained one and just say this is a base, this is an acid. And hopefully this will be more familiar to you once you understand how to draw a Lewis structure, and you can understand this really easily.